Hello everyone, myself Vibhu. Today I'm going to discuss about some of the MCQ questions which belongs to 10th CBSE current electricity chapter. This time 10th CBSE as well as ICSE students will be writing their semester exams. In the semester exams there will be MCQ questions. So some questions which I have taken from current electricity chapter might be helpful for you people in the upcoming exams. Okay, so let's see what is the first question. The rate of flow of charges is called as option A voltage, option B resistance, option C current, option D potential difference. So basically first we'll see what is charge. Okay, charge is the basic property of any body. Every body has a charge. There are two type of charges are there. One is positive charge, another one is negative charge. The charges are basically represented with the alphabet Q, correct? Okay, sometime we will represent with the small letter Q, or some time we will use uppercase, all right? But here are the some options given. First one is voltage. What is voltage? Voltage is the pressure created by a source like cell or battery to push the electrons, okay, where those electrons will helpful in the illumination of the bulb. I have shown here one image, okay, where the shell is there. From this cell, positive terminal is negative terminal is there, which is connected to a bulb. When this bulb will create the voltage or pressure, that will makes the electrons to move in the circuit. When the electrons move in the circuit, obviously the current will flow, okay, charges will flow, so then the bulb will glow. This is what we will call it as voltage. And option B says that resistance. Resistance is the opposition for the flow of charges, or the disturbance for the flow of charges. Option C, current. What is the meaning of current? In generally, I can say that current is anything is flowing. For example, water is flowing in a river. So I can say as water current. Wind is blowing. I can say that wind current. So in the same way, when the charges are flowing, when the electrons are flowing in a conductor, I can call it as a electric current. Okay. Next one is potential difference. Potential difference can be represented as V. V equals W divided by Q. W stands for work done. Q is the charge. What is potential difference? Potential difference can be defined as the work done in carrying a unit charge from infinity to that point. Okay, so now the right answer for this question is current. So the rate of flow of charges is called as current. Okay, so current is represented with alphabet I. I equals Q by T. Okay, Q stands for charge, T stands for time. What is time? Time is the duration between any two events. Okay, let it be. But current can be symbolically write as I equals Q by T. Current can be defined as rate of flow of charges. Okay, all right, we'll move to the next question. SI unit of current is option A volts, option B ohm, option C watt, option D ampere. Okay, so for example, let me say that length is represented in, SI unit of length is meters, right? So we know that temperature can be taken as Kelvin. In the same way, we have to represent the current also. How to represent the current? What is the SI unit? SI unit of the current is ampere. Okay, ampere is the scientist name. So or else we can say that alphabet A also, A stands for amperes. So let me say that in a conductor, there is a 2 ampere of current is flowing, 10 ampere current is flowing, 4 ampere current is flowing. So A stands for ampere. Okay. So, and option A is volts. Volts is the unit of potential difference, or voltage also measured with the unit of volts only. Okay. Next one, ohm. Ohm is the unit of resistance. Okay. Resistance is the disturbance for the flow of charges. Watt. Watt is the unit of power. Okay. But right answer for this question is option D, amperes. So, and I have here attached one image that is represents ammeter. What is ammeter? Ammeter is a device basically used to measure the magnitude of the current flowing in the circuit. Okay, all right. We'll move to the next question. Third one, the hindrance presented by material of conductor to the smooth passing of electric current is known as option A, resistance, option B, conductance, option C, inductance, option D, none of this. Okay. So here option A says that resistance, right? But we'll see the question in detail. The hindrance means the disturbance, obstacle provided by any conductor for the smooth, easy flow of the electric current is known as resistance. As we discussed in the previous question, resistance is the obstacle or hindrance or the disturbance for the flow of charges in a electric circuit. So what is conductance? Conductance is the property of any conductor till what extent it will allow the charges to flow through it. Okay. So basically I can say that it is the basic property of any conductor or a material that will say that till what extent a charge or an electron can flow through it. Next, inductance. Inductance is the one of the important property of the again conductor, where will creates the EMF in the circuit, or it will make sure that the charges are flowing in the circuit. That property is called inductance. Okay, but the right answer for this question is resistance. Okay. Fourth one, a fuse wire is inserted in which wire? Okay, what is fuse? Okay, we can see the image here, right? Fuse is a safety device for any electric circuit. For example, in our house, there is a meter board is there. The meter board is the place where the current will enter from the external circuit, right? So where there is a fuse is there, it will act like a security guard. So how security is required for school or an apartment. Okay. So in the same way, the fuse is act like a safety device. It will make sure that, it will not allow the excess current enters the circuit. If there is a chance of excess current entering the circuit, it will cut, or it will disturb the flow of that excess current. So basically it will break the circuit. So by breaking the circuit, it will safeguard, or it will save the electric appliances or electric network. So fuse is very, very important. So the question is where the fuse wire is inserted or connected. Okay. Generally, there will be 3 type of wires will be there in the electric circuits or electric network. First one is live wire. Option B in the neutral wire, option C in the earth wire, option D may be connected in any line on any wire. Okay, as I said that our domestic circuits contains 3 types of wire. Live wire is the main wire, is where the main current flows. Okay. Option B, neutral wire. Neutral wire will carry the current to the source from where we are getting the electricity, maybe power station. So in generally, you can see the two wires, right? One is live wire, another one is the neutral wire. Okay, in the live wire, the main current will be flowing. It is represented with the red color. Okay, so and the neutral wire may be blue or black in color. So where it will make sure that the circuit is complete. Okay, and option C says that earth wire or the ground wire, it is one of the most important wire in the electric network, where the excess current will be drawn or thrown into the ground or the earth. So it is basically represented with green color. Okay, but where exactly the fuse wire is connected? The fuse wire will be connected to the live wires. Okay, clear? All right, so the right answer for this question is option A. Fifth question, the rate of flow of electric charge is known as. Again, it is similar to the first question, but a few words are added here. The right answer for this question is electric current. Okay, electric current can be defined as the rate of flow of charges. Okay, so I can say that I equals Q divided by T. Sixth one, the instrument used for measuring electric current is. So option A, ammeter, option B, galvanometer, option C, voltmeter, option D, potentiometer. See, if you take any circuit, electric circuit, sometimes it is required to check that how much current is flowing in any electric circuit, right? See, for example, the body temperature can be measured with the thermometer. Heartbeat will be checked with the help of stethoscope, right? In the same way, in any conductor, how much current is flowing, how much current is passing. To measure that, we require an instrument or a device that is called as ammeter. Okay, I have attached the image here. Ammeter is an instrument used to measure the magnitude of electric current in the circuit. Next, option B says that galvanometer. Galvanometer is one more instrument which is basically used to detect the current in the circuit, whether the current is there or not. Okay, we cannot use the tester and all. So in the laboratory, generally we use galvanometer. So it will give the idea whether the circuit is dead or live. I mean to say that whether the current is flowing or not. And also the galvanometer will show the direction of the current flow, in which direction the current is flowing. So galvanometer is one of the important instrument used to detect the current in the circuit. Next, voltmeter. It is also one kind of instrument basically used in an electric circuit, which will give the idea about like how much potential is there. What is the potential difference in the circuit? That can be measured with the help of voltmeter. Option D, potentiometer. Potentiometer is one of the most important instrument basically used to find out the EMF of the given cell, electromotive force. Okay, or it is used to find out the internal resistance of the given cell. Every body, every conductor will produce some percent of resistance, right? Even the cell or battery will produce the resistance. Inside the cell, there is a resistance, right? That is called internal resistance. So a cell, how much resistance it is producing, that can be measured with the help of potentiometer. So, but right answer for this question is option A, ammeter. Seventh question, the amount of work done in joules when 1 unit of electric charge moves from one point to the another point in an electric circuit is called. Okay, option A, electric current we have discussed. The rate of flow of charges is called electric current. Option B, resistance. Resistance is the opposition for the flow of charges. And conductance is the property of the material or a conductor, till what extent it will allow the charges, or it will make sure that the charges are flowing smoothly or easily. That property of a conductor is called conductance. Next, option D says that potential difference. Okay, so the right answer for this question is potential difference. Potential difference V equals W divided by Q. Okay, so joule is the unit of the work. Okay, the amount of work done when one unit of charge moves from one point to the another point, okay, in an electric circuit, is called as potential difference. Okay, so the right answer is option D. Question number 8. The relation between potential difference V and current is this. Here option A, V is directly proportional to I square. Option B says that V is inversely proportional to current. Option C, V square is directly proportional to I. Option D, V is directly proportional to I. According to Ohm's law, okay, we know that V is directly proportional to current. According to Ohm's law, we can say that applied potential difference across the terminals of the conductor is directly proportional to the current flowing through the circuit. So the right answer for this question is V is directly proportional to I. When you apply the potential, then how much ever the potential you apply, that much current will start flowing through the conductor. You increase the potential, then obviously the current will automatically increases. So if one increases, another quantity will also increases. So the right answer for this question is option D. V is directly proportional to I. Ninth one, the electrical resistance of insulator is option A high, option B is low, option C 0, option D infinitely high. So basically the electrical resistance of an insulator will be high only. What is insulator? Insulators are the solid or a solids which basically allow the which will not allow the charges to flow through it. I mean, which will allow the the disturbance. I mean, it will create the disturbance. Okay, the rubber, plastic, glass are the best example for the for an insulators. So in generally, I can say that insulator means where it will opposes the flow of charges. So here in the insulator, it will be high. Okay, the resistance will be high. So the right answer for this question is option A. 10th one, the relation between potential difference and current was discovered by. Okay, so as I told in the earlier cases, V is directly proportional to I, or I is directly proportional to V. So I can write it as V equals IR, right? This is the important mathematical formula or expression for Ohm's law, right? So here the options are Newton, option A, option B, Ampere, option C, Ohm, option D, Volt. So Newton gave the different idea about laws of motion, okay, gravitational law. Okay, this is all from Newton, we can say that, right? And Ampere, his contribution is completely into the electricity. Okay, he gave the different idea about the current and the charges. And comes to the Ohm. Ohm is the scientist or physicist who gave the idea or the relation between the voltage or potential difference and the current. Okay, and Volt is the one more important scientist in our life. So who discovered or invented cell or batteries. Okay, but right answer for this question is option C, Ohm. 11th one, The SI unit of resistance is option A Newton, option B Ohm, option C Watt, option D Joule. Okay. So we know that Newton is the SI unit of force, right? All right. Ohm is the SI unit of resistance. Watt is the SI unit of power. And Joule is the unit of energy. Any kind of energy, maybe potential energy, kinetic energy, right? Okay, so now right answer for this question is option B. Okay, Ohm. 12th one. Which of the given statement is not true regarding the electrical setup for the verification of Ohm's law? Okay, verification of Ohm's law is one of the important experiment which will be done in the laboratory. Okay, so let's see what are the options they have given. The first option, okay, the voltmeter is connected in parallel with the known resistance. Okay, obviously, voltmeter is an instrument used to measure the potential difference in the circuit. It will be connected in the parallel with respect to the given devices. Okay, parallel. Okay, next one. The ammeter is connected in series. Yes, obviously, remember this. Ammeter is connected in the circuit in series. Voltmeter in parallel with respect to the given devices. Okay, and come to the rheostat. Rheostat is an instrument basically used to vary the resistance in the circuit. Obviously, when you vary the resistance, even the current will get vary, right? So the rheostat can only increase the resistance in the electric circuit. So we have I have attached one image here, so we can see the image here. This is all about rheostat, and the single key is used to switch on or off the electric circuit. Okay, so key means what? Key is nothing but switch. Switch is a device or it is a bridge between the the two terminals. So key will act like turn on or turn off the circuit, right? So which is not true here. Okay, so remember here they have given the rheostat can only increase the resistance in the electric circuit. But remember, rheostat can increase as well as decrease the resistance in the circuit. Without touching the voltage source, we can vary the current in the circuit. That is by changing the resistance in the circuit. So the right answer for this question is option C. So here it should be increase and decrease. So here I just gave some idea about rheostat. Okay, the component used to regulate current without changing the voltage source is called variable resistance, or so rheostat. In an electric circuit, rheostat is often used to change the resistance. Change means either you can increase or decrease in the circuit by either increasing or decreasing the resistance. Okay, so this is all about rheostat. Remember this. Next question. Okay, a voltmeter is used to find potential difference in any electrical circuit. Which of the statement given below is true? Okay, so we'll see quickly. So voltmeter is a high resistance instrument and connected in series. As I told, the voltmeter will be always connected in parallel, so it is wrong. So next one, a voltmeter is low resistance instrument and connected in series. Again, it is series, so it is wrong. A voltmeter is the high resistance instrument and is connected in parallel. Okay, as I told, it is a high resistance instrument plus it will be connected in parallel. Option D, a voltmeter is a low resistance instrument and connected in series. So wrong. So basically remember the right answer for this question is option C. It is a high resistance instrument plus it will be connected in parallel. Remember this. Okay, we'll move to the next question. So for this question, the right answer is, 13th question, option C. Next one, 14th one. The resistance of a conductor does not depend upon the, okay, option A, length of the conductor, option B, thickness of the conductor, option C, temperature of the conductor, option D, humidity of the conductor. See, resistance basically depends on length of the conductor, material of the conductor, thickness of the conductor, and temperature also one of the important factor to decide the resistance, right? So in a metallic conductor, if the resistance increases, means obviously in the temperature also increases, it means, right? When the temperature increases, resistance will increases. So, and come to the humidity. Humidity will not matters here, or humidity will not affect the resistance of a given conductor. So the right answer for this question is option D, humidity. Doesn't matter here for the electric circuits. It will not affect the resistance of the electric circuit. So the right answer is option D. 15th question, in parallel combination of electrical appliances, the total electric power, option A increases, option B decreases, option C does not change, option D remains the same. So in generally we can see there are two type of electrical combinations or connections. One is parallel combination and series combination. In parallel combination, what will happen? The total power of the electrical circuit will be equal to the sum of the individual electric appliances. Okay, so basically I can say that the total electric power of the electric appliances will increases when it is connected in parallel. Remember, so the total electrical power will be increased. How? By adding the individual power of each appliances. So the right answer for this question is option A. 16th one, if length of the conductor and its radius is increased twice, and how the resistance will change. Option A, resistance will remain same. Option B, resistance increases twice. Option C, resistance will become half. Option D, resistance will increase 4 times. So now what I will do here, see here, we know that resistance equals rho L divided by A, right? This is the basic resistance formula, but they are saying that resistance is increased, length of the conductor is increased and radius is increased twice. So now what I will do, R equals rho, where the length is increased twice, as well as area I can written as pi r square, right? So but what I will do, they are saying that even the R also increased twice, right? So rho 2L divided by pi 2R whole square. So here, so now what I will write here, so what I'll write, 2, because radius also increased, right? 2R whole square. Okay, so where area equals pi r square, the formula, right? So now what will happen, rho 2L divided by pi 4 r square, correct? So now what I will do, 2 ones are 2 twos are, correct? Can we write like that? So now what will happen, rho L divided by 2 pi r square, is it right? So now what I can write, rho L whole divided by 2a, right? Because pi r square is nothing but area, right? So now what is happening? So it is almost equal to resistance only. But can you see the formula here? R equals rho L divided by A. So, but here once we increase the length and radius by twice, what happened? It will become R equals 1 by 2 rho L divided by A, right? So it is basically multiplied by 1 by 2. You can see here. Okay, 1 is not there, so you can take 1 by 2 rho L divided by A. That is nothing but resistance, right? So I can say that the option C says that resistance will become half, right? So compared to this, initially it was R equals rho L divided by A. Rho stands for resistivity. Okay. Okay, rho. Okay, rho stands for resistivity. Initially, before changing the length or radius, it was R equals rho L A, right? Divided by A. But when you increase both length and radius, so after simplifying, we got 1 by 2 rho L A, rho L divided by A, right? So it is basically multiplied by half. So resistance will become half. So the right answer for this question is option C. Next, 17th one, how the charges will flow. Option A, by heating them. So if there is a one conductor, will you heat it? Will the charges will flow? Will you keep in the sunlight? Will charges will flow? No. Okay. Option B, by applying potential difference, by applying the battery connection. Yes, obviously, when you connect the battery or a source of energy to a circuit, so charges will start flowing in the circuit. Okay. So the right answer for this question is option B, by applying the potential difference, the charges will flow in the circuit. 18th one, the obstruction offered by material of conductor to the passage of electrical current is known as. So the option A says that resistance. So we already discussed similar kind of question. Okay, so resistance is the disturbance or hindrance or obstruction for the flow of charges. So the right answer for this question is option A. 19th one, the potential difference applied is directly proportional to current only if. So as we studied earlier, V is directly proportional to I according to Ohm's law, right? If it is only satisfies when the temperature remains the same. When the temperature varies of the conductor, even the resistance will vary. If the resistance vary, means what will happen? The whatever the current will decreases, right? So resist to make the current same. I mean to say that the potential will be directly proportional to current. I mean potential and current will be same means, so where the temperature of the conductor must remains the same. If temperature varies, resistance also vary. Resistance vary, current will vary. Okay, so the right answer for this question is option D. 20th one, on which of the given parameters specific resistance depends? Option A, length of the wire. Option B, area of wire. Option C, current passing through it. Option D, temperature. So the specific resistance is basically depends on the temperature of the uh, given material. Okay, remember, so temperature increases, what will happen? Even the resistance also will vary. So the right answer for this question is option D. 21st question, which of the following gases are filled in the electric bulb? Option A, helium, neon, both are rare gases. Option B, neon and argon. Option C, argon and hydrogen. Option D, argon and nitrogen. So right answer for this question is neon and argon will be filled inside the bulb, incandescent bulb or the tube light, any kind of electric bulbs. Why they will fill with these gases? First point, I can say that they will increase the lifespan of the bulb, and they will decrease the they will slow down the temperature of the filaments which are there inside the bulb. So basically neon and argon are the rare gases. It will be there inside the electric bulb. So the right answer for this question is neon and argon. Remember it. 22nd one, 1 kilowatt hour equals. So 1 kilowatt hour, right? 1 kilo means 1000. So 1000 watt, okay, into hour. 1 hour equals. Okay, so 1000 watt into 1 hour means 60 minutes into 60 seconds, right? So 1000 watt into 3600 seconds. I mean 60 into 60 is 3600 seconds, right? Now 1000 into 3600, so that is basically 36 lakhs. Okay, so now what will happen? So it is very difficult to remember such a long number, so we'll make it short. Now by putting the decimal number, what I will do, 1 2 3 4 5 6. So after 6 numbers I'll put the decimal point. So dot 3.6 into 10 to the power 6 joules. Okay, so the right answer for this question is option C, 3.6 into 10 to the power 6 joules. So here I just shifted the decimal from here to here, here to here. Okay, I exactly shifted 6 numbers. That's why I'm raising the power of the 10 by 6. So the right answer is 3.6. And I have taken the unit as joule. Okay, all right. Next question. An electric bulb is connected to a 220 volts generator. The current is 0.50 ampere. What is the power of the bulb? So basically the power equals V into I. Okay. This is the one formula which taken from Ohm's law. So what is V? V equals 220. And what is I? I is 0.50. So how to do the multiplication? 0 into 0, 0, 0 into 2, 0 here. Okay. Next 0 into 2, 0, correct. Next 5, 0, 0, 5 2s are 10. I'll keep 1 here. 5 2s are 10, 1, 1. So 10 plus 1, 11, right? Next 0, 0, 0, 0, right? If you multiply 0 with 0, 0, 0 into 2, 0, 0 into 2, 0. Now what will happen? 0, 0, here 0, 1, 1, right? But after, how many decimal points, after decimal point, 2 numbers are there, right? So in our answer also, we have to put decimal point here. So the right answer for this question is 110 watt. Watt is the SI unit of the power. We must write the SI units with the results, right? So the right answer is option B, 110 watt. 24th one, what is the commercial unit of electrical energy? The commercial unit means like whatever the electric bill we will get in our domestic purpose, right? In that bill, what kind of unit they will mention? They will mention kilowatt hour. So the right answer for this question is option C. 25th one, electrical resistivity of any given metallic wire depends on. Okay, option A, its thickness, option B, its shape, option C, nature of the material, option D, its length, right? First, we'll see what is resistivity. Resistivity is the property or characteristics of any given material. Till what extent it will opposes or disturbs the flow of charges. So if you take a bad material, so obviously more resistance will be there, right? So if you take the good conductor, obviously resistance will reduces, decreases. So basically while choosing the material, we have to choose the right material for the electric circuits. So basically we will use copper wire in our domestic purposes, aluminum. We can use silver or gold, but they are costlier, so we cannot use it. We can use it, but because of the money, we cannot use those gold or silver. But copper is a common conductor, we are using it, right? So because whose resistivity is less. So what is resistivity? It is the characteristics property of the material that up to what extent they will opposes the flow of the charges. So the right answer for this question is option C, nature of the material. Okay. 26th one, the instrument used for measuring electric potential is. So option A, ammeter. Ammeter is used to measure the current in the circuit. Galvanometer will detect the current in the circuit, whether current is there or not. A potentiometer is basically used to measure the internal resistance of the cell or to compare the EMF of the given cells. Okay, and come to the option C, voltmeter, right? Voltmeter is an instrument basically used to measure the potential difference or voltage in the given circuit. This is the voltmeter image which I have attached here, right? Electric power is inversely proportional to. So option A, resistance, option B, voltage, option C, current, option D, temperature. We know that power is rate of doing work, right? P equals W by T. But we already know that V equals W by Q. Is it right? So can we write W equals V into Q? Correct? Can I substitute in this equation? So what will happen? P equals VQ divided by T. All right. But we already know that I equals Q by T. Is it right? From the definition of current. So now here you can see Q by T. So instead of writing Q by T, I'll write I, right? Because I equals Q by T, right? So now, but we already knows that from the Ohm's law, V equals IR, but I equals V by R. Is it right? So now what I will do, I'll substitute this in this equation. So now what will happen? So power equals V into V by R, correct? So now V into V square. So divided by R. So now all together I can write it as P equals V square divided by R. So power is directly proportional to voltage or potential difference, and power is inversely proportional to resistance. So the right answer for this question is option A, power is inversely proportional to the resistance. And here is the formula, and these are the steps. You can write it down. Okay, all right. We'll move to the next question. 28th one. When electric current is passed, electrons move from. Okay, very important question, and most of the students will get confusion in this question. As I've seen from in many students. So let me draw the electric circuit. So this is the battery connection is here, right? So the positive terminal and negative terminal, positive and negative. Bulb. Okay, now what is happening? The current is flowing in this direction. The current will flow from positive terminal to the negative terminal. This is the switch. Okay, key means switch. So now the current is flowing from positive terminal to negative terminal. But electrons are there in this negative terminal, right? They will flow from the negative terminal to the positive terminal. So the direction of the current will be always opposite to the direction of flow of electrons. Okay, so remember, current will flow from positive to negative terminal and electrons will flow from negative to positive terminal. Okay, so remember, the right answer for this question is the electrons move from low potential to the high potential. So the right answer for this question is option B. Okay, and as I said here, the current will flow from positive to negative and electrons will flow from negative to positive. This kind of the current flow is called conventional flow of current. Okay, all right, so the right answer is B. So thanks for your time, thanks for watching. Okay, if you really like this video, kindly like and subscribe. Also share with your friends and relatives. Okay, thanks for your support once again. All the best for your exams. Okay, keep sharing, subscribing and supporting. I'll be updating a few more questions in my upcoming classes. Thank you very much.